Dear viewers, greetings. In this video, we are going to learn how to extract frames from a video every second using Python. In the previous video, we have learned how to download a video from YouTube using a tool known as YTDLP. Remember, we are still working on dataset preparation. We have just downloaded the dataset footage from the YouTube channel Benax Media. Let's see the video we have just downloaded. It's here, and we can open it. We have the video and we are going to learn how to split frames out of it. Instead of video, we need images or frames for further steps in the data preparation. What's a frame? A frame is a single still image from a sequence that, when played in rapid succession, forms a video. Frames are essential because they allow us to analyze specific moments within a video. Extracting frames is especially useful when analyzing individual images is needed to identify or track specific details. That's the case in applications like object detection, video surveillance, and automatic number plate recognition, which is our current concern. Let's look at the code now. The code starts by importing important libraries. This is OpenCV, this is OS, this is AgPass. Let's check what every library or what each library does. OpenCV in this script is going to handle image and video processing. It will provide the methods to open and read frames and to get properties like frame rate and to save frames as image files. The second library is OS, which is going to interact with the operating system. In this script, OS is used to check if the folder for saving frames exists and to create it if necessary. It will also help in creating file path for saving each frame. The third library is AgPass, and it's gonna pass command line arguments. It will allow the script to accept a video file path and output folder as command line arguments. This makes it flexible and easier to use with different import files and output locations. So the code is straightforward. We get an argument or a video path as argument, and we pass it using AgPass. And once we get a video path, we will use OS to see if the folder into which we want to save the frames exist. If it doesn't exist, we then create it, and then comes OpenCV, which is going to open a video, and OpenCV will continue to help us to read the frames, split the frames, and save the frames. So in summary, this is what the code does. The code defines the video path and output folder. It creates folder if it doesn't already exist. And the code opens the video and calculate the frame interval to capture every second. And the code loops through frames and save each one that matches the interval, naming it sequentially with 4 digits. Then it finishes the frame capturing process by releasing the video from memory and printing a completion message. This is what this code does, even though the code seems a little bit long, but it's straightforward. So let's go and run this code. What you can just do is to copy this code and in my case I have this code already, but if you don't have it, you will use the editor to create it. For example, it's here already from my case, but if you don't have it, you can create it and then run it. Do you know why? Because I didn't mention the video file or the path to the video. So I run the code and add the path to the video. But it says it doesn't find this, and that means I need to wrap it up in quotation marks. Here we go. It will take a while. That's why we may close here. And thank you for your attention. Let's see each other in the next video.